Welcome to lecture series on signals and systems. In this lecture, we will start a new topic of discussion, that is LTI system. Okay. A system is said to be a LTI system if it obeys the linearity and time invariance properties. Okay. So LTI is the linear time invariant system. Okay. So in the previous videos I have discussed in detail when a system is said to be a linear and when the system is said to be a time invariant. Okay, so please go through them for a better understanding. Okay. So here the first point of discussion in this unit is about the representing the discrete time signal in terms of impulses. Okay, so by the statement you can understand any discrete time signal x of n can be represented in terms of delta n. Okay, so how it can be? A unit impulse signal is said to be used as a basic signal to construct any discrete time signal. Okay, so that is, any discrete time signal can be represented as a sum of shifted scaled unit impulse sequences. Okay, so how it can be represented? It is a sum of shifted scaled unit impulse signals. Okay, so the better understanding of this one, we will do that using some signal example. Okay, here you can see consider a discrete time signal x of n as given below. Okay, like you can see here, it is varied from -1 to 1 and its amplitude is -1, 1 and 2. This is a given x of n, and this x of n we can be represented in terms of delta n. How it can be done? So we have a better property of impulse signal is when it is multiplied with any signal. This is the impulse signal. This exists at n equal to 0 only and its amplitude is 1. Okay, so when it is been multiplied with the original signal, it will generate a single impulse. Okay, it will generate a single sample, you can say. Okay. So here you can see there are 3 indices values are there, like n is varied from -1, 0 and 1. Correspondingly we will have 3 expressions. Okay, so we will go by one. So if suppose x of 0 is multiplied with the delta n, what we will get? Mathematically we can write x of 0 into delta n is equal to x of 0 only. Okay, for only n equal to 0. So other than 0 n, the value is 0 only. Okay, so graphically you can represent that signal x of 0 delta n as x of 0 only, because x of 0 यहाँ पे 1 है तो यहाँ पे भी 1 आएगा. Okay, similarly in the second part we can write x of 1, because the signal exists at x of 1, into delta n minus 1 has to be multiplied with this. Okay, so n minus 1 is the shifted impulse signal. Okay, so you can say a shifted impulse signal value is 1 for n equal to 1. So you can say x of 1 delta n minus 1 equal to x of 1 for n equal to 1. So other than 1 it is 0. So graphically you can say at 1 only the value of the signal exists. So what that value? This is x of 1. But what about x of 1 in the signal? It is 2, right? So at 1 it will be 2. Similarly in the third case, x of -1 delta n plus 1, it is the left shifted signal now. Okay, so its value will be x of -1 for n equal to -1, otherwise it is 0. So graphically we can represent that at -1 it will have -1 amplitude, because it is there here in the x of n. Okay, now what I can write x of n as? X of n I can write it as x of 0 into delta n plus x of -1 delta n plus 1 plus x of 1 delta n minus 1. So as you can see, I am adding all these 3 signals. So if I add them, at 0 I will have 1, at 1 I will have 2, at -1 I will have -1. So that is the x of n. Okay, so this is the one important representation of discrete time signal in terms of impulse signal. Okay, in continuation, generally, that is for a particular example, generally what could be the expression for x of n, that is any discrete time signal in terms of impulse signal. Okay, so that I can write it as in terms of expressions. You can say from it will start from -infinity. As you can see, this signal can be any values. Okay, so from -infinity to +infinity it will go like this. So x of -2 into delta n plus 2 hona chahiye, because 2 left shift has to be done here. Then x of -1 into delta n plus 1, 1 left shifted, x of 0 delta n, and x of 1 delta n minus 1 right shifted by 1 unit here, and multiplied with x of 1, x of 2 into delta n minus 2, like this it will go. Okay, so this is the representation of signal. And mathematically how I can write here in general form, x of n is equal to summation k equal to -infinity to infinity x of k delta n minus k, okay, where k is varied from -infinity to infinity. And what is this delta n minus k? Delta n minus k is the shifted impulse signal, and its value will be 1 for n equal to k, and it will be 0 for n equal to not k. Okay, so anything value that is not k, it will be 0 only. Okay, so this is very important representation of discrete time signal in terms of unit impulse signal. Now the second point of discussion here is we can have a impulse response and the convolution sum. Okay, so what is this impulse response? Impulse response is nothing but, consider a system here, and this is an LTI system actually. Okay, this is an LTI system, and suppose for this LTI system, if delta n is the impulse input signal and the output is represented as h of n is the impulse response. Okay, so simply you can consider one more example here shown below, like x of n is equal to x of n is the input given to the LTI system here. This is an LTI system, and it produces the y of n. So what exactly this y of n expression will be? It is some t kind of an operations, some operation, time related operations performed on the x of n, right? So here x of n is an input discrete time signal, y of n is the output after some operation on the x of n. Okay, so if this input signal is the impulse signal and the output whatever I am getting, that I will call it as impulse response. That is the word impulse response. Okay, so you can see here, and that is represented as h of n. Okay, so delta n is the input signal to the LTI system, and it produces the output impulse response, and that is nothing but t of delta n, similar to this expression. Okay, now from equation number 2, substituting equation 1, or you can say from equation 1 and 2, we have y of n is equal to t into x of n. X of n is what? Summation k equal to -infinity to infinity x of k delta n minus k. So that I will substitute here, and now you can have this interchange of this summation and the transfer function. So it will be y of n is equal to summation k equal to -infinity to infinity x of k t of some time related operations on delta of n minus k. Okay, so why I can interchange this one? Because it is already a LTI system, so there is a linearity already. Okay, so linearity comes when the system is said to be linear if it obeys the superposition principle or a property, and that itself says that it will be holding the additivity as well as homogeneity. Okay, so this is about that. Okay, and that I will consider it as equation number 3. Okay, next similarly what I can write, some time related delta n minus k. Here you can see this time related operations on delta n minus k is nothing but what? it is something like, consider shifted input signal delta n minus k itself is the input to the LTI system, and obviously it is producing response as h of n minus k. Okay, how we can say that it is producing h of n minus k itself as the impulse response for this input? Because the transfer operation of on the input signal delta n minus k produces h of n minus k due to time invariant system, because we are considering this is an LTI system. So whatever the amount of delay exists in the input signal will produce the same amount of delay in the output signal. Okay, so that's why I can write time related operation, that is t of delta n minus k, as nothing but h of n minus k. Okay, so this is nothing but here. Okay, what is this? Time related operations on delta of n minus k can be written as h of n minus k. So this is equation number 4. Now equation 4 in equation number 3. Okay, so equation number 3 is this one. Okay, so instead of this t of delta n minus k, I will replace it with the h of n minus k. So simply we will write y of n is equal to summation k equal to minus infinity to infinity x of k h of n minus k. Okay, so what is the conclusion here? So output of an LTI system is given by weighted sum of time shifted impulse response. Okay, understand it, I will read it once again. The output of an LTI system is given by weighted sum of time shifted impulse responses, and it is called as convolution sum. Very important property of an LTI system. Okay, so convolution sum is represented as y of n is equal to x of n asterisk, or you can say star h of n. Okay, so this asterisk is the convolution operation. Okay, and this representation of this impulse response, weighted sum of impulse response, is giving us a separate properties, some very important properties. So we will quote one of the few of the properties of the convolution here. The first one is distributive property. So as it is saying here, you can say, consider this is how the system is there, like x of n is an input signal and h1 and h2 of n are the responses of the signal. So it can be written as x of n convolution h1 of n plus x of n convolution h2 of n. This is equation number 7. And similarly, this is the distributed. Okay, so convolution can be distributive. Second one is associative. Okay, so how it can be associative? So here also there is an asterisk here. So this is not a plus sign, this is also an asterisk, and here also it is an asterisk. So x of n, h of n is convolved, and the convolution of h2 of n. Okay, so you can write x of n convolution h1 of n convolution h2 of n. So this can be possible. This is an associative property. Okay, so convolution obeys associative properties also. Okay, so apart from that, there is other few properties. Commutative property. So what is this commutative property? Okay, so h1 of n convolved with h2 of n is nothing but I can interchange them like h2 of n convolved with h1 of n. Okay, then shifting property. So what is the shifting property? X of n minus k convolved with h of n minus m is producing y of n minus k minus m. Okay, so please understand here, the amount of shift whatever it is generating, the same amount of shifting will be there for the output also. Okay, so whatever the two signals which are there in the convolution will produce the same amount of shifting. Okay, so convolution with the impulse. So if I convolve this, something like x of n is convolved with delta n, will produce x of n only, and convolution with the shifted impulse like x of n convolved with delta of n minus n naught, this is the shifted impulse signal, will be equal to x of n minus n naught only. Okay, so these properties are very much important for some MCQ type questions in the examinations, like you can say even it will helpful for you in the competitive exams. Okay, so this is about the convolution sum. So convolution sum is the output of an LTI system which is represented in terms of weighted sum of time shifted impulse responses. Okay, so we will see for the steps to do the convolution sum. Okay, so you will be given with the x of n signal and you will be given with the impulse response of the signal. Okay, that is the impulse signal is given to it and it has been response, uska response jo hai wo dekhte hain. Now if you convolve them, what will be you are getting the y of n. Okay, so how to calculate it, how to find the convolution sum of two sequences. So uska steps hai, so there are around 8 steps. Here it has been quoted. I will go through one by one. So first step says choose an initial value of n. Okay, how to choose an initial value of n for the y of n? Because y of n is what? X of n convolved with h of n. Okay, so x of n can have the different starting point. Say it is having n1, and h of n can also have a different starting point. So say it is having n2. And what about n? So n will be usually n equal to n1 plus n2. That is the better start of the y of n. Okay, so how it can be understood here? Starting value of n for an output sequence y of n can be understand. Suppose x of n starts with a n1 and h of n starts with a n equal to n2. Then n equal to n1 plus n2. This n is the starting point for the y of n. Okay, so this is for even better understanding also. You don't have to follow exactly in this manner only, but for the examination point of view, you can consider for a verification. Okay, like n will be n1 plus n2. Step 2 saying represent the given signal x of n and h of n in terms of h of k and x of k, because that's what our formula says. It is summation k tends to infinity to minus infinity to infinity x of k h of n minus k, right? So we will be representing n to k, n ke badle k dal dete hain. Okay, that's the first step. You can say correspondingly if it is not that much been observable. Third point is perform the reversal on the h of k. So that is nothing but from the h of k obtain h of minus k. Okay, h of minus k. Then in the fourth step, what it says, whatever the h of minus k is there, that has to be shifted by n units. Okay, so how many unit it is there? So that will be decided according to this calculation. N equal to n1 plus n2. Okay, so n units ko shift karna hai to obtain h of n minus k. Okay, so preferably how you have to understand this one is do the left shifting. Okay, left side shift. Whatever h of minus k is there, do the left shifting of h of minus k such that h of n minus k will start at n equal to n1 plus n2. Okay, so while solving the problem, you will have a better understanding about these steps. One by one, some more problems if you solve, then you will have this picture of steps. Okay, then in step 5, what we will be observing, find the regions of overlap between the h of k and h of n minus k. So we have to see for the overlapping. It means a common n indices between the h of k signal and h of n minus k signal. If there is a overlap or there is a similarity, they has to be multiplied and they have to be added, otherwise it is to be 0. So what is the step 6? Multiply the two sequence h of k and x of k and h of n minus k element by element and sum the product to get y of n. So that's what the formula is. Okay, so if you look into the convolution sum formula, what it says, x of k is there, and now we will have the shifted h of minus k also by the n in it, so that is nothing but h of n minus k. Now find the overlaps. How to find the overlaps? It is nothing but simply multiplying the element by element of the x of k and h of n minus k and sum them to get y of n. Okay, getting sum the products to get the y of n. Now increment the index n. Okay, so suppose initial value of n1 is 0 and n2 is minus 1. If you add them, n will start at minus 1. Okay, so next it has to be incremented, so it is n equal to 0 here, and do the same thing like step 4 से सब ये करना ही है. Okay, then repeat the step 7 and do the step here. In step 7 says increment the index n, shift the sequence h of n minus k to the right by one sample, and do the step here it has to be step 6. Okay, it has to be step 6, and step 8 says repeat step 7 until the sum of product is 0, that is whatever the step 6 output we will be getting, that is y of n, is 0. In other words, it is something like finding the non-overlapping sequence, that is there is no overlapping sequences between the x of k and h of n minus k. Up to that point we have to shift one position, do the multiplication by element in both the signal, add them, same thing it will be continued. Okay, so this is about the steps to find the convolution sum of two sequences. Okay, so we will have a simple clarified discussion on this by taking one example here. Okay, so here it is been given, find convolution between x of n and h of n. Okay, given by x of n as 1 2 3 and h of n as 1 1 2 2. Okay, so I don't have to repeat this one, wherein we have seen this graphical representation and functional representation, tabular representation of discrete time signal. So in that it says that wherever this arrow is there, that tells you the zeroth line, zeroth index value. So here n equal to 0. Correspondingly, this is at 1, this is at 2, and this will be at minus 1. And here if there is no arrow mark given with a signal, that means it starts at 0 only. Okay, so simply the first step is to plot this one here accordingly, because there is no plot given in terms of representation. अगर हम graphical representation करना है तो इसको पहले plot कर लेते हैं. So x of n is 1 2 3 for the n value 0 1 2. 0 1 2 के लिए 1 2 3 signal आ गया. This is x of n. Similarly h of n is 1 1 2 2 corresponding to minus 1 0 1 2. This is h of n. Okay, x of n, h of n are there. Now according to the steps whatever we have discussed, we can say in the step 1 n equal to n1 plus n2. So look at n1. n1 is x of n. X of n starts at 0, so here n1 will be 0, and n2 is h of n starting signal. This is at minus 1, so n2 is minus 1. Now if you add them, n will be minus 1. So with respect to this only we have verified that our y of n will have minus 1, this will have some value for n equal to minus 1. Okay, so before n equal to less than minus 1, y of n equal to 0. Please understand this one. That's what our understanding with respect to the first step. Second step, represent the according to the step what it says, represent the x of n and h of n in terms of x of k and h of k. X of k and h of k. Simply what? Instead of n here, that will be k terms. So here you can say there is a k term. okay, and this is h of k and this is x of k. Okay, now what is the third step? Obtain reversal on h of k, that is h of minus k आना चाहिए. So what is this time reversal? Whatever the values of indices are there, they will be negated. So accordingly here it is -1 को negate कर दिया तो +1 हो जाएगा. So whatever we have at -1, that we will have it in 1. Similarly at 0 it is 0 only. At 1 we had 2, here it will be at -1, negation of 1 is -1, यहाँ पे amplitude 2 आएगा. At 2 we had 2, so at -2 we will have 2. This is h of minus k. Okay, whatever the fourth step says that whatever h of minus k is there, that has to be shifted by n units. Okay, so it has to be shifted towards the n units. So how it will be? So n units shift कर दिया, so it is something like each and every index value of k को n से plus कर दो. So this is nothing but plus n plus n plus n. प्लस n करने के चक्कर में क्या होता है, यहाँ पे लेफ्ट शिफ्टिंग होता है, बिकॉज वी आर डूइंग द प्लस हियर. अगर माइनस करते हैं तो राइट शिफ्टिंग होता है. सो दैट्स व्हाई इट इज n n+1 n-1 n-2. ओके, नाउ in the step 5 what it says, we have to find the region of overlaps between what? Between x of k, here I will write x of k and h of n minus k. Okay, so to find these overlaps we will have a certain cases. Okay, what if this n+1 is something? Okay, so here some cases are there. Okay, how to find these cases we will see. If n+1 is less than 0, it means that what I am saying, अगर मेरा कंसिडरेशन है n is less than -1 मैं कंसिडर करूंगा. सो व्हाट आर द रीजन ऑफ ओवरलैपिंग? ओके, सो अगर n is less than -1 क्या होता है? देयर इज नो ओवरलैपिंग सीक्वेंसेस. सो एट दिस पॉइंट यू कैन से व्हाटएवर दिस n+1 इज दैट, दिस इज लेस देन 0. ओके, दैट इज n इज -1 रहेगा, तो लेस देन -1. सो कंसिडर इट कुड बी n equal to -2 होगा. कंसिडर it has to be less than -1, not equal to -1. Okay, so I will take it for n equal to -2. At n equal to -2 पे क्या होता है? This is at -2 and this is at -1, this is at -3 and this is at -4. So find the overlapping regions between h of n minus k and x of k. So obviously I can say there is no overlapping here because it starts at 0 and at 2, and here it starts at -4 and at -1 according to this example. Okay, so there is no overlapping. That's why for this case the y of n is 0. For what? For n less than -1. Okay, so you can say here for a no overlapping regions, that's why it is 0. Second case. Okay, second case में क्या होता है? I will be starting counting for n+1 equal to 0. That is the last signal जो भी h of n minus k का है, this is starts at 0 because why we are considering 0? At this point x of k is there, no? Okay, so n+1 will be 0. Correspondingly what I am saying, n equal to -1. So here you can say y of n is equal to h of k, x of k, h of n minus k. This is the representation, right? So what I am observing, y of -1, तो उसके लिए क्या होगा? x of k क्या होगा? यहाँ पे x of k, यहाँ पे एक रीजन है, at 0 I have 1 and at h of n minus k पे क्या हो गया? Because this also starts at 0, there is also signal. So from both the signal we can consider there is a one overlapping sequence, and what we need to do for the overlapping sequence, we need to multiply each and element by element and add them. So since only one element is common, so उसका दोनों का amplitude multiply किया 1 into 1 and we will have 1. So at y of -1 we will have 1. Similarly for case C, if so we are shifting, so it is the next step wherein it is step 7 wherein the index value of n is incrementing by 1, right shifting by 1. So now n plus 1, that is the start of this, is starting at 1. So n plus 1 is at 1. This is the third case, case C. Okay. So what will happen? Correspondingly n plus 1 पे यहाँ पे 1 आया, 0 पे 1 आया, at, so you can say here it is n plus 1 equal to 1 consider किया तो n equal to 2 होगा, right? Sorry, n equal to 0 होगा. Okay, n plus 1 equal to 1 consider किया तो plus 1 हो गया, n equal to 0 हो गया. So what I am calculating, what will be the value at y equal to 0, right? तो उसके हिसाब से क्या होगा, कितना 2 overlapping sequences are there, because it also exists at 0 and 1, it also exists at 0 and 1, that is x of k and h of n minus k. So all these signals are h of n minus k only. One shift is done on the right side. Okay. So 2 overlapping sequences are there. For this, what we have to do, whatever the elements which are common, they have to be, their amplitude has to be multiplied element by element and they have to be added. So simply here at 0 we have 1, here also at 0 we have 1, so 1 into 1, plus at 1 we have 2 here, and here at 1 we have 1, so 2 into 1 it is 3. So total कितना हो गया, 1 into 1 plus 2 into 1, this is equal to 3. Okay, at y of 0 we will have 3. Okay. Similarly, now again one shift is done. So how many shifts we have to do till this y of product y of n leads to 0, तब तक ये शिफ्ट करना है. तो उसके हिसाब से हमारा केस डी आ गया. अभी केस डी क्या होता है, अगेन वन शिफ्ट कर दिया तो योर स्टार दिस सिग्नल h of n minus k will be at 2, correspondingly 1 0 minus 1 तक आपका h of n minus k होगा. This is also h of n minus k. Now if you compare the h of n minus k with the x of k, there will be 3 overlapping sequences. So these 3 overlapping sequences can be considered like this. Again multiply them, saying case D here 1 into 2, because you can see here there is a amplitude 2 here, this is 1 1. Okay, so and here the amplitude is 1, so 1 into 2 plus यहाँ पे amplitude 2 है, यहाँ पे amplitude 1 है, so 2 into 1 plus यहाँ पे amplitude 3 है, यहाँ पे amplitude 1 है, so 3 into 1. So तीनों को ऐड कर देंगे, अभी मल्टीप्लाइड सिग्नल को ऐड कर देंगे, this is 7. So at y of n we will have 7.